Hi everyone. Hey, let's take care of a few more terms in Physical Science 5. The next term is acceleration. Acceleration is a change in velocity. And remember that velocity is a vector quantity. So there's two things, size and direction associated with vectors. So for velocity, velocity describes both speed and direction. And so acceleration is changing the velocity, and it can be either the speed or the direction, and both are considered a change of velocity, hence that's caused by acceleration. When you're measuring acceleration, typical units are meters per second squared, and sometimes students question, well, what's that squared sign doing in there? Well, let's kind of explain that a little bit by beginning with units for velocity. So velocity, or really not the direction component, but the speed component, has units of meters per second. Meters per second. And so that means if you're measuring speed, you're telling someone how far, how many meters they can go for every second. And that's the same if you change the units to miles per hour. The per, the P, means divide. So miles per hour is miles divided by hours, and it's a measurement of speed too. And then acceleration is, well, one way to describe acceleration is by describing how it changes the speed, which means it's going to say how the miles per hour or the meters per second change. Is it going to increase or decrease? And is it going to speed up, accelerate that is, more quickly, or is it going to be a slow and steady kind of acceleration? It's going to speed up a little bit more. So in other words, how fast does the velocity change per second, right? So if a car starts at 0 miles per hour and it slowly speeds up to 10 miles per hour, well, how long did it take? How much did it increase in speed per second? Acceleration describes how fast the velocity changes per second. So you can take the units of velocity, which are meters per second, and per means divide, so we divide again by seconds. So there's a second down in the denominator. Sorry, that was bad. The units for acceleration then become meters per second for velocity per second, or meters per second squared. Okay, if you don't like that, let's try something else. Let's see. Acceleration due to gravity. That's equal to 9.8 meters per second squared. And you know what? In this class, we can just round off the whole numbers. So we can round off acceleration due to gravity to 10 meters per second squared. And sometimes you use the little symbol G to represent gravity's acceleration. And what does that mean when we talk about the acceleration due to gravity? Well, just for an example, let's put a rock on the edge of a cliff and give that rock a little shove. Get it to start falling. Okay, just as it tips over the edge, its speed going down is 0 miles per hour, or let's use the metric system, 0 meters per second. Okay, so it starts at that, and then after 1 second, it has sped up. It has increased its speed, its velocity, by this amount, 10 meters per second squared. Or in other words, it is 10 meters per second faster after 1 second. For every second per second, it speeds up by 10 meters per second. So what we're going to do is take the initial velocity, 0 meters per second, and add 10 to it. And so the speed after 1 second is now 10 meters per second. And the rock might be here. And then let's let it travel another second. Well, it starts at 10 meters per second, and then after the next second, the second, after 2 seconds, it's going even faster. How much faster? Well, it began at 10 meters per second, and the acceleration is that for every second it goes 10 meters per second faster. So now the speed is 10 plus 10, 20 meters per second. Okay, and keep doing that. For every second, add another 10 to the speed. And that's acceleration. How fast is the speed changing for every second? This is a case of free fall. The rock is freely falling off of the side of the cliff. And we're going to assume that there's no air resistance. Normally air will slow an object down from falling. But to simplify the mathematics and just to consider it a little more easily, let's assume there's no air resistance.
2, 1, go!
Okay, that was a fun little video illustrating free fall, jumping off of a platform onto an airbag. And here's some things we talked about already. There's no air resistance. The acceleration due to gravity for that person jumping off the platform, we're going to round off to 10 meters per second squared, and that means the acceleration changes the velocity 10 meters per second every second. Okay, there's a nice little equation here that tells you how far the person has fallen, or that rock we had falling off the cliff. If you know how long it's been falling, you take that quantity and square it, multiply it times itself. Multiply it by the acceleration, in this case it's gravity, 10 meters per second squared, and then multiply it by 1/2. It's a nice little equation to do that. So let's see, as an example, let's say that rock has been falling. Rock falls for 3 seconds off of the cliff. And so if we want to know how far it's fallen, then we can take this equation and calculate it. So the distance is equal to 1/2 times 10 meters per second squared times 3 seconds squared. So just kind of follow the math here. Let's group the numbers together. So 1/2 times 10 times 3 squared, and then let's bring the units together. We have meters per second squared times second squared, this s and that 2, right, second squared. And then s squared divided by s squared is equal to 1. Those cancel out. And then the distance is, well, let's do this math right here. 1/2 times 10 is 5 times 3 squared. 3 times 3 is 9. And the units are meters. That's good. That's a unit for measuring distance. And then 5 times 9 is 45. There we go, 45 meters. That's how far the rock falls in free fall after 3 seconds. Thanks for watching.